All right, great. Thank you so much, everyone, for joining. Really great to see you all again. We were off last week, so it's great to have everyone back together again. Today, we're going to be having Sebastian talk about substreams-js. Really excited for this one. Sebastian is from Avant-Garde Finance, and he's very active in the community, and I'm sure he's got something really awesome to show us today. From what I understand, he's going to do a presentation and a demo. So thank you, Sebastian, coming on, and welcome.
Thanks for having me. Right, so yeah, I'm going to talk about substreams.js, but I'll also go a little bit into the weeds and talk about something that I realized that I actually do want to talk about much more, which is some of the underlying principles that made the development and creation of substreams.js possible in the first place. And why I think that we have some really good decisions backing the substreams tech stack that will make adoption and using substreams really, really cool in the future. So anyways, first, obviously, let's start with the substreams.js overview, and then go a little bit into the roots and come back around to substreams.js and demos at the end. Always bet on JavaScript. It has its quirks. But it's ubiquitous, and you can't really avoid it. It's in the browser, it's in Node.js. We have Bun recently, there's Deno. There's so many different runtimes that rely on JavaScript these days, and you can run it on the edge, you can run it in the browser and on the server, which makes it a tool that you can barely avoid. And yeah, always bet on JavaScript has been coined many times. I think it's very true. And it's also why I've been stuck with JavaScript and Typescript in particular for the past decade, I'd say. And yeah, still very happy building JavaScript applications. And it's much more powerful than people realize. So substreams.js was created as a port of the Substreams Go package, which is not only the CLI, but a lot of underlying APIs and features backing the CLI, not only for consuming substreams modules, but also for manipulating and packaging them. The goal of the Typescript port of the substreams package, of the Substreams Go package, is, however, not to be a full replacement of the CLI capabilities of the Go package, but rather to provide access to these lower level APIs so that you can build bespoke solutions in JavaScript, which is obviously much more accessible to a large part of the existing graph community, and build bespoke solutions on top of that. It runs everywhere. We've built it with full portability in mind. So it's modern JavaScript, ECMAScript modules, pure ECMAScript modules. We don't currently have a CJS published on NPM. If this is something that people need in the future, we can add it. But so far, ESM has been treating us fairly well. It runs in Node, it runs in Bun, it runs on the edge, AWS Lambda, Cloudflare, Workers, Vercel functions. We have tested it across the board. It also runs in the web. We do also have some web demos already. There's, for instance, the Substreams Vercel app demo that is also available here as an open source Next.js application right in this repo under Apps Playground. You can see that here in the Git repo. And there's also other teams already building on user interfaces around it. You can use substreams.js to consume substreams modules, so process output of substreams packages. You can use it to read and validate manifests. That means you can also use it just like you can do it with the Go substreams package to process the contents of a substreams YAML manifest, and then unpack, pack, and repack packages, substreams packages, that is, that can then be processed or uploaded somewhere and shared with the community. This is interesting because it means that you can also, for instance, interesting feature we discussed recently, open a substreams package in the browser and replace a module within that substreams package in one kind of like a WYSIWYG editor with a substreams module from another package that has the same I/O signature, so the same input requirements and output protobuf message types. And just repackage it as a new substream, and then consume data from that. And recently, we also added a new sync package to this repo, which will allow you to run and create your own bespoke syncs in Typescript, based on a very robust foundation with very robust error handling, retry capabilities, and failure handling. That's still in the making though. And there's already an example in here, which I'll demo later. But this is going to let you write substreams syncs for whatever you can imagine in Typescript, which I imagine is more accessible to a large part of the community. Right. So, but as I mentioned earlier, I want to go a little bit in the weeds and explain why substreams.js came to be and why I think this is not the end. There's more going to be available in this ecosystem in the future because of some good decisions and ideal timing by the fine folks at Streaming Fest and in particular Alex, who has essentially advocated since the beginning to protobuf all the things. And it doesn't end with protobuf as the underlying message format for the substreams modules that you're writing in Rust. It actually goes beyond that, because protobuf is our message format of choice, not only for the output of substreams modules, but it is also the things that we use for packaging substreams and for processing and accepting substreams on our substream services API. So substreams modules, if you've worked with them already, you notice you have Rust. You're writing these substreams in Rust, but you're defining the message formats in protobuf, and you also run them on a gRPC service. This is maybe less clear to people because this is already now happening behind the scenes when you're using a substream sync or when you're using the substream CLI. So what is happening behind the scenes there is the substreams package that you have created within your editor and packaged with the substream CLI, then gets sent to a gRPC service, which is the protobuf service definition, and then is processed on that server and produces the messages that you previously created when you wrote that substreams module or those substreams modules. And those messages are then returned to you and either written to your sync or logged into the console, whatever you're doing right now. So you can see here when we are sending that substream package or your module that you wish to consume to the gRPC service, you get progress indicators in the response, and you get data from your substream package. But that's not all. What's interesting is that substreams packages themselves are protobuf messages or are protobuf images, so-called file descriptors. And this is interesting because it sticks to the protobuf scheme that we have adopted throughout our tooling here, and it makes it very versatile, very portable, and very easy to integrate in any language. On any platform, and very easily document the structure of everything. And it's basically, instead of adopting a custom binary format for our packages, we are literally just rewrapping them as a standard, well-known protobuf message type, and then serializing them as a binary and saving them on disk. In these protobuf images, we are essentially compiling the manifest or metadata from the manifest, the protobuf messages or the protobuf schema that you are creating for your substream, and the compiled WebAssembly code from your Rust code for your substreams modules. Right. Protobuf is great. They're faster and slimmer and more widely adopted message formats, but Protobuf strikes this perfect balance between portability, adoption, and tooling. There's a lot of tooling available these days. I'll come to that in a second. But also message sizes, right? Obviously, JSON would be much more widely adopted, but it has a much larger footprint when it comes to the wire, egress, ingress of the data that is sent and produced from substreams. Protobuf strikes this really good balance, and recently, Protobuf has seen. Next slide. Come on. Recently, Protobuf has been getting its second wind from this awesome team, Buff Build. They have contributed lots of interesting open source projects to the community over the last 2 years, I'd say. First of all, obviously, there's the Buff CLI, which is a new Protobuf tool that kind of replaces the Proto-C CLI. They have also shared recently and made it production ready the schema registry, which we also use for all of our substreams Protobuf definitions. So that's where you can find also a published version of all of the substreams proto definitions from Streaming Fast. And they have also shared and developed a new standard called the Connect protocol, which is a extremely portable, simple and accessible API abstraction around gRPC. And what's great about the Connect protocol is that already today, the Connect protocol is available for Node, for Kotlin, for Swift. So you can do Android and iOS development also for Node.js and in Go, of course, right? So this is also already widely adaptable across different platforms, which makes this also the tool of choice in our Typescript abstraction in substreams.js. And obviously, fundamentally, like they created also the latest version of the Protobuf ECMAScript implementation, which is much more modern and portable than the previous gRPC.js variants. So a lot of contributions here from their side, and this is why I think the timing was just right for substreams to go all in on Protobuf, because nowadays it is really possible to also use gRPC on the web. Previously, I'd have always said that gRPC is a service-to-service abstraction and message format. These days, I'm not so sure anymore. It's absolutely feasible to use gRPC and Protobuf also in the browser now. And that was also going to enable us to build tooling in the browser and demos and abstractions and user interfaces for substream modules right in the browser. And this is also what people have built already. Well, we're going to see that in a demo later. Right. Connect, I mentioned it. So Connect, again, just a very simple and portable abstraction around gRPC, available in multiple different languages. Right. Let's dive in and do a demo. In the browser, we can, this is the demo of the also deployed tool and open source code that I mentioned earlier. So this is also available in the substreams.js repo as a tiny little playground here. It's a Next.js project. You can run this locally and then have it available here on localhost 3000 as I have right now. But it's also deployed. It's on substreams.versal.app. And what this is simply here to prove is that you can not only load and inspect substreams packages in the browser. This is actually going to open a substreams package here, and you can see all of the metadata from the unpacked package here. And not only can you also show the flowchart of all of the modules, but you can actually stream data from a substreams package right in your browser. This is quite interesting because it might enable use cases where you want to either demo like a substream live or want to observe real-time data from Chainhead. For those use cases, obviously, this could be a viable solution. Under normal circumstances, however, I have to say you'd always probably process, because the amount of data coming through here is already, like you can see the data flying by here and the blocks passing in the thousands. Normally you would run this and pipe it into a sink, right, into your database or whatever. But this is still, I think, a really good visualization of the capabilities of the Typescript abstractions. And going back into the code, I also wanted to show how easy it is to create this. So, for instance, this is a bit more involved, obviously, because it has a whole user interface behind it. But in order to consume a JavaScript or consume a substream with JavaScript, literally with this library, all you need is about 50 lines of code. You load a substreams package. You define which module you want to use, and then you just call the gRPC service in this code here. And if I open this now, with these 50 lines of code or so, we get, in a second, hopefully, yeah, we get the message streaming here too. This example, or all of these examples, also the simple ones that I'm opening here right now, this one is, for instance, streaming ERC20 tokens, is available also in the repository. You can try them out quite easily. All you need is a substreams API token. This one would be the example web right here. And you see it's just the index.ts file here. That's all you need. Right. Secondly, you can also, or thirdly, I'd say, you can also consume substreams in Node. And what I wanted to show is the work in progress around the substreams things. And the code or the abstractions here, because what's critical with substreams is that you also track state and cursors and keep your substream recoverable in case of failure. And all of that can get rather involved. Obviously, you need to track the cursor. You need to make sure that you provide some guarantees between the consuming of the stream and writing into the sink. Exactly once delivery of the data, or at least once delivery. You want, obviously, in case a failure occurs, to reconnect automatically and continue from the point of the failure. And ideally also track some metrics and so on. So what we have here is all of that, just the same as in the substreams sync package from the streaming file guys, but in Typescript. We have retry capabilities for all kinds of error scenarios. You can decide whether you want to retry forever, whether you want to retry 100 times, or for a certain time period. You can track metrics and write them into Grafana or whatever you are using for metrics in your case. And when you run this, you get all of that output now in the CLI. And so obviously, this would be one version of consuming the substream, but you could also, and that demo also shows it here, we are writing them into a file in this case. Yeah, I have to actually open the file here. So, but you see there's data appended. Now we have 17 lines, and the cursor is being tracked too here. And in order to do that, Where do we have this? Yeah, this is literally all the code you'll have to write for your custom things. Yeah. As far as I'm concerned, we can go into questions, ideas, and feedback. Thank you.
I have a question. Why should someone write a custom thing in Typescript and not directly in the substream with Rust?
Well, you can still, you would still write, or you can still write your sync abstraction using the standard protobuf sync definitions that we have available for entity changes and so on, or for database changes in Rust, and then process them here in TypeScript land. Or you create a bespoke sync for your specific substream, right? What you can also do is write a specific substream and then generate the protobuf definitions into TypeScript and consume that bespoke substream with a bespoke sync in TypeScript and, for instance, trigger web service notifications or, specifically for the actual low-level messages coming out of that substream module. But the reason why you want to use TypeScript here instead of Go or instead of another language is simply because TypeScript is more widely adopted, has a lower barrier of entry, and it just runs everywhere.
Okay, that's a great reason. So, any plans of going in the direction of being able to write substreams modules with TypeScript?
This is currently in development. I'm not involved in that, but as far as I know, Matt and Alex have been experimenting with that. But yeah, you'd have to ask them.
Yeah, I do that regularly.
Yeah, but it's a good point. Initially, I was actually opposed to that because of the previous pains we have experienced with subgraphs and assembly script. Fracture or potentially fracturing the community into writing their substreams in different languages. I think there's a benefit in having everyone writing their substreams in Rust and publishing these substreams crates so that they can also be reused on that code level, right, and not just as a substreams packages. But I can see the value in lowering the barrier of entry for developers wanting to develop substreams packages also in TypeScript.
Yeah, I agree with the concerns here, actually. But yeah, I kind of like how you framed it initially, like JavaScript. What was the quote? JavaScript is everywhere.
Always bet on JavaScript. Yeah, I think that's very true.
It's still the most used language.
Yeah.
By far.
Yeah, never underestimate JavaScript. It's just everywhere. It's so easily adopted. The number of developers using it daily is nothing else comes close. Any other questions or ideas for how to further improve this?
I mean, I definitely need to play around with it, but like one use case that comes to mind, but like it's probably not easy to do right now is so if someone has a subgraph and wants to have live updates in the front end, I mean, the specification is done by the guild with live queries, but that's not implemented, unfortunately. But someone could use the graph client to then query that subgraph. But what it needs to have a trigger to know when it needs to, because it's basically a polling thing. So yeah, my side project here would be taking a subgraph, using Graph Client with live queries on top of that subgraph, and then using substreams-js and a very simple substream that only knows about like what's an event emitted on that contract that needs me to requery that or resend that GraphQL query to bring everything a little bit together, because it's also like a frequently requested feature of subgraphs.
Yeah, that's what I mentioned earlier, where this might be used in a scenario where you have both state that you query and then afterwards live updates in the browser directly. I'm not sure, depending on the use case, you might want to have a server in between that handles both and gives you a smarter abstraction around it. Instead of like querying from the browser and then starting a substream on the client, you might have the substream actually running on the server and just running it once and then sending updates to the client through like a WebSocket connection or HTTP long polling. This is a possibility.
Yeah, I agree. But that's the cool thing about Graph Client, that it runs in the browser, but would also run on Cloudflare workers or whatever. So like whatever the I don't know. I mean, I would say like the level of decentralization that the app developer wants to have is kind of up to their discretion, right? I think maybe if you're a degen DeFi protocol that does stuff that SEC would immediately kind of go after, then you might want to go higher with decentralization. But if you're just, I don't know, like doing a social network or I don't know, then you probably want to go to more easier stuff.
Yeah. I mean, what I mainly did with substreams.js so far was writing this bespoke things where I'm not actually using a protograph sync standard like database changes or entity changes, but instead actually just streaming specific modules, data modules out of a substream. Like in this case, for instance, the Uniswap pools, and then in JavaScript, generating through the buff CLI that I mentioned earlier, generating the protograph into Typescript classes for that specific substream, and then handling them in JavaScript by, for instance, writing them into a database directly, or doing some post-processing, or running web APIs like Slack notifications from this, triggering them from this JavaScript application. And just purely because of that low barrier of entry, this is something that also my team can very easily then extend and work on.
Great stuff. Looking forward to play around with this more when I find time, and then I'll give you more feedback. But I have to jump now. But thanks so much for the presentation and for that library. I really like it.
Great. Yeah, and if anyone wants to try it, I'm also in Discord, in the Substream channel. Just ping me and ask if any questions if you run into any issues.
Cool. Thank you.
All right. Then everyone, take care. Have a nice evening. Well, rest of your day, wherever you are.